Hi everyone, a very good morning to all. Now we can see about an introduction to adaptive filtering and its applications. First of all, what do you mean by linear filters? Actually, linear filter output is a linear function of the filter input. So there are two methods to design linear filters. So one is our classical approach and second one is optimal filter design. So the classical approach, there will be a frequency selective filters such as low pass, band pass, notch filters, etc. Whereas in optimal filter design, mostly based on minimizing the mean square value of the error signals. Adaptive filters. The signal or noise characteristics are often non-stationary and the statistical parameters vary with respect to time. An adaptive filter is an adaptation algorithm that is meant to monitor the environment and vary the filter transfer function accordingly. So usually, adaptive filters is based in the actual signals received, attempts to find the optimal filter design. So there are two operations involved in adaptive filters. So first one is filtering process and second one is adaptation process. What is filtering process? So in filtering process, we will be producing an output signal in response to a given input signal. Whereas in adaptation process, we aim to adjust the filter parameters such as filter transfer function to the environment which is time varying. Often, the average or square value of the error signal is used as the optimization criterion. Because of the complexity of optimizing algorithms, so most of the adaptive filters are digital filters that can perform digital signal processing. When processing an analog signals, the adaptive filter is then preceded by analog to digital converter and digital to analog converters. So the generalization to adaptive IIR filter leads to stability problems. So it is common to use a FIR digital filter with adjustable coefficients. So next is some applications of adaptive filters. So first one is identification. Applications of adaptive filters. So first one is identification. So it is used to provide a linear model of an unknown plant. Example, system identification. So we'll be giving an input to the plant. So this input is given as input to the adaptive filters, and based on the decision making devices, it will be giving an original signal as well as the error signal. This error signal will be feedback as input to the adaptive filters, and finally, while summing the adaptive filter output as well as the plant output, we will be getting the system output. So next one is inverse modeling. So it is also used to provide an inverse model of an unknown plant. For example, equalization. So next one is a prediction. So basically LPC, that is linear predictive coding, is one of the applications of adaptive filters. So next, echo cancellation or interference cancellation. It is used to cancel unknown interference from a primary signal. For example, our hands-free car phone, aircraft headphones are coming under echo cancellation. So next, applications of adaptive filters. That is, it is used in system identification, inverse system identification, noise cancellation, and predictions. So these are all some of the applications of adaptive filters. Digital communication, which is based on OFDM, MIMO, CDMA, and RFID. Channel equalization, adaptive noise cancellation, adaptive echo cancellation, system identification, smart antenna systems, blind system equalization, and many others. Thank you.